present because this is, to me, one of the most significant things. This is the projects panel. You're going to get a good overview right now about some of the most significant research, some of the most promising initiatives that the Scientific Coalition for UAP Studies currently has underway. And so I'm going to do a very quick, brief introduction for each of these speakers, and they're going to give you some perspectives on some of these exciting projects that are underway. Immediately right here beside me, we have Peter Reali. He's the Project Development Director and a member of the Board of Directors of the SCU. Of course, he has his BSEE and MSEE from the University of California, Berkeley in Statistical Communication Theory, Digital Design, Engineering, and Computer Science. He also worked for many years in Silicon Valley as a director and manager of electrical design, engineering projects with a specialty in telecommunications, and he's going to be providing an SCU projects overview. Beside him, we have Robert Powell. I'm sure most of you have bought Robert's book, and you know Robert very well. If you haven't bought his book, you need to. But Robert is a founding board member of the SCU. He has co-authored several scientific reports in addition to his books, and these include, most notably, a forensic analysis of Navy Carrier Strike Group 11's encounter with an anomalous aerial vehicle. Of course, we're referring to the famous Nimitz incident, some of those military personnel here present this weekend. And Robert was the primary author, serving as secondary author of another paper estimating flight characteristics of anomalous unidentified aerial vehicles, published, by the way, in our friend's journal, Entropy. Dr. Kevin Knuth, and of course, again, some of our personnel here contributed to that as well. Now, Robert, again, just released that book I was telling you about, UFOs, A Scientist Explains What We Know and Don't Know. He's going to brief us a little bit today on the SCU's AIAA Shape, Size, Kinematics, EM Effects, and Sound Characteristics study. He's going to tell you about all that and what it means. Joining us remotely, we'll have Ian Porritt. He's a seasoned analyst working in the research and development area with over 30 years of experience in New Zealand, Australia. He holds a bachelor's degree from Massey University in New Zealand, and aside from his professional accomplishments, he's also an amateur astronomer with a passion for helping to unravel the mysteries of our universe. Joining us here present, and right down there on the end, Mr. Gary Stephenson holds a Bachelor of Science in Physics and a Bachelor of Arts in Philosophy from Montana State University, as well as a Master of Engineering in Space Systems Engineering from Stevens Institute of Technology. He has over 30 years of experience as an aerospace engineer with basically all the best names in the business: Hughes Aircraft Company, ITT, Raytheon, the Boeing Company, UTC Hamilton, so many more. But today, Mr. Stephenson is going to be providing us with a brief on the SCU's Gravitational Field Propulsion Research Project, which I'm extremely excited to hear about. So, please welcome our panelists. And I think we're going to lead off with Mr. Reali. Peter, if you'll go ahead and you'll lead us off here with this SCU projects overview. You can actually do it right there and use that if you'd like, yeah.
Can you hear me? Yeah, okay. I got to remember not to drop the microphone. Okay, let's see if I can flip the slide here. Okay. I'm, after that wonderful lunch, I'm, moving slow here. So, the SCU, this is a great event, and it keeps getting better all the time. And I'm going to talk. I'm project director, but really what I do now is try and shepherd projects and get the people on board so that other people can do the work. And we have we're really growing and things are really moving along. But I have a short list here of some of our active projects and just the leads for it. And, you got to appreciate people. Many of these people are working. And, it's all voluntary. And so we need all the help we can get. And I'll talk about that a little bit later. But one of the first ones is Tim Oliver. And he's an Australian PhD and heads up the Propulsion project. And I'll describe a little bit later about what those are about. Ralph Howard, who is here, I think he's still here. Raise your hand, Ralph, if you're out there. It has a drone project. And what we're doing there with the drones, I'll also talk about. Larry Hancock is heading up the intention study, which has to do with the security and government security have to do with different events, UAP events around atomic sites and the carrying it on into the future. And he's done 3 papers, and Ian Porritt's going to be he works on that group, and he's going to be talking about that. And of course, yesterday you heard us talking about with Doug Kimsey, the database project, which you know, we're working on, and hope to have that, you know, well, we have a prototype, but hope to have it actually operational in a few months. And then Anna Kovac, who's maybe online, but she's heading up the USO project, and that's has to do with underwater submersible objects. And there's several people on that, and I can't list them all here. I'm going to talk a little bit about these projects that are active right now. The Propulsion project is really what Tim Oliver has like 4, and Gary is going to be talking about that today. And the idea of this project is we're not going to figure out how UAPs are you know, how they actually move through space, what the kind of engines they have, basically. But what we want to do is, through historical signatures of these kind of events, you know, they are reported like in our database and those kind of things. Certain kinds of signatures are quite common. And these different kind of propulsion mechanisms that are proposed, we want to see if some of them are more probable and would match a certain kind of propulsion mechanism. And we would get a little bit more information about how this works and maybe lead to research in that area. The way I see the SCU is we're trying to motivate academia and you know, scientifically based people to take these as real, you know, as actually scientifically based events. And these things are really happening. And the more we do our papers for that and convince people that these things are real, which has been so ridiculed, you know. So there's like, we have like 4 things going on here. One is a computational fluid dynamics, which Tim Oliver is working on. That looks at the effects through the atmosphere, through physics, of how these things behave and whether, you know, how they're reported as transmedium. What kind of an energy field would be required so that they can transfer through the atmosphere and not have any effect? They don't heat up, they don't produce any kind of sound or anything. So that's one aspect. The other one is magnetohydrodynamics. That's a proposed propulsion system that uses, it ionizes a field in front of it, and through a magnetic field actually can propel itself. The other one is general relativity, which you know, Gary is going to talk about today, which is my favorite because I think it, in that particular one, I think some kind of warpage of space could explain almost all the signatures. But I'm not a physicist, but it's, you know, my intuitive ideas, I think that's a great one. Another one is Dr. Detlef Hoyer, who lives in Germany, is working on five-dimensional Kaluza-Klein metrics. It's still active in physics, but you add another dimension to general relativity, and what you do is it proposes new force fields that would allow perhaps to elevate an object and propel it through space. You know, so all of those are being activated. You know, if we can make some progress on that and produce papers, it'll move us ahead. The other project I talked about, Ralph Howard's heading up the drone project. We have, you know, 3 or 4 people working on that. The FAA has produced databases over the years of unusual events that pilots see, and they entered in this database. And, you know, if it's an airplane or something like that, but when they come up against something that they don't really know what it is, the only thing they can check off is a drone. And we are very suspicious that many of these objects that are called drones are really UAPs. So doing a study of this statistically, of their speed, altitude, I mean, some of these things are 30,000 feet and flying at, you know, 400 miles an hour, and, you know, there's no drone we know of that can do that and go on and stay with the airplane for half an hour, you know. That doesn't fit a drone. The SCU database, we talked about yesterday, so I won't talk about that. The Intentions Statistical Project, which Ian is going to talk about. He'll fill you in on that. And the USO I talked about a little bit. Over the years, that's one of the most difficult projects because there's so little data. But there are, in fact, I assumed that a USO was an object that it's a UAP that goes in the water, and some people think that's the case. But if I looked up the definition of it, it's supposed to be something that's just underwater. It doesn't really mention leaving it and going into space. So stay tuned. We'll find out what's going on there. So. I'm going to talk a little bit about this, but if you look at I was going to model it. If you look at the SCU as a ship, then our conferences are sort of like the lights, the flag, and the radar. It lets us know that you're there, and it kind of helps out. The board of directors and the board advisors are sort of like the crew, but the actual projects are like the engine room. The people that without projects, the ship doesn't go anywhere, and so it's extremely important. And I'm doing everything I can to make us go somewhere. And so on our webpage, if anyone's interested, we like to attract people. It's ever growing what our needs are. There's a help wanted page, which you can see here. You can just go on our site and find that. But we're looking for technical managers and project managers because not everybody wants to lead a project. There's a lot of work there to coordinate people and get things done. You can also work on the actual project, but we need people that maybe they're not super technical, but they've led projects and can organize people and that kind of thing. That's very valuable to us. We also, of course, are looking for physicists, engineers, and mathematicians, because we're science-based. And you saw, like, through Dr. Butner, I'll put it that way, what it took to analyze that. And that's not uncommon. Some of these papers, like Robert and I worked on the Nimitz paper for a year and a half, and we have to be careful about what we take on and analyze because there's a kind of a return on investment. In business, return on investment is how much money you put in it. But what is our capital? Our capital are human resources, and we want to put them on something that produces a return for the SCU. So that's my way of looking at it. We're looking for software development because there's now a lot of software, involved in these things and having that. Statistical specialists, a lot of the analysis because, on data and, it requires statistical analysis. You can't just say something is true. You have to have a good basis for it. And so the other was database specialist, which we'll talk about. Another one that's artificial intelligence is becoming big, and we have some people on each of the projects that are using artificial intelligence, but this stuff is just starting to what it's going to be. And I look forward to having a group that specializes, that could actually consult with different projects to actually apply the latest in artificial intelligence. Now, those are all nuts and bolts. I'm a nuts and bolts guy. I like data and facts and those kind of things, but there are a lot of other aspects to this thing that, and so we want to do something on, at least it would be interesting to start some projects on, like with geneticists, evolutionary biologists, and xenobiologists. Xenobiologist is someone who studies the possibility of life on distant planets, those kind of things. And there's plenty of ideas for projects on that. Also, social science academics, things like what is the influence that if someone sees a UAP, it's been observed, it changes their whole life. And, you know, not the same person afterwards. And what does it do to society? You know, what if they landed tomorrow? You know, what would happen? And, you know, so it's a social science kind of a academic approach. Of course, web and PR-based people, public relations people, we need those very desperately. And someone to keep, you know, right now the web is kind of kept, we have a few volunteers, but, you know, we'd like to have somebody permanently or a group that would permanently maintain the web and take care of it, because it's, you know, it's a need that has to be done. The other one is financing the SCU. We would like to have government and grant writers to help us get grants and be able to move ahead with these kind of projects that we want to do. So we have a Help Wanted page. So if any of you, I know there's a lot of probably technical people, but it isn't just technical people. We have needs in a lot of area and just wide variety. So, you know, if you want to help the SCU, you can apply at, probably should change the name from projects, but just the Help Wanted page, and we'll try and fit you in just to get help with the project. So I won't go into, you know, all this kind of stuff right now, but I'll turn it over to the people here. But anyhow, I can ask questions later at the end. So thank you.
Excellent. Thank you, Peter. I think we'll move on to Robert Powell now, another of our executive board directors. And Robert's going to talk a little bit about the AIAA shape, size, kinematics, EM effects, and sound characteristics study.
Thanks, Micah. Let's see. I'm pressing down. Oh, okay.
We're just getting that slide loaded there.
I can't bypass your computer over there then.
And hence, Robert, we've got to tell jokes in the meantime.
All right.
Yeah. Anybody know any good jokes? That was kind of funny.
Oh, I'll start off a little bit. This particular project that I'll be talking to you about, Peter didn't mention this one because it's a completed project, but we're still doing papers on the project. No apology necessary, Peter. Because it's a completed project, and Peter was showing you current and future projects. So this is our first paper. We plan on having a second paper that came out of this project. So the reported shape, size, kinematics, electromagnetic effects, and presence of sound of UAP from select reports. And this is the time period 1947 up through 2016. The individuals, myself, Dr. Sarah Little, and Sarah did a lot of work in making this a good paper in terms of how you structure the paper and the thoughts and the science that goes into the paper. Larry Hancock did a lot of the work with me on identifying the cases that we used. And then Leba Hassan and Robinson Trong and Toby Kamuru are three students from the University of Toronto that worked with us on this case. And I think it's important as you do work in this subject, and this is one thing I wanted to say that Beatrice did, you saw earlier. She included students from Nigeria and Algeria in her project. I think it's very important that we include the young generation, just like Doug Bittner did and one of his students from the University of Utah. Okay, I already went through about the authors. So in this project, we took databases and analyzed them. We analyzed specific cases in the databases. So on this slide, what I'm trying to give you a feel for are these are some of the major databases that exist on the UAP subject. If you look on the left, those are basically military databases. And the key thing to see as you look at those is those are from all around the world. Everything from Project Blue Book, which was the United States, down to GPON, which is the French data collection system that's still going on today. On the right side are civilian databases. And these civilian databases that I've listed are basically US databases. But there are similar databases in all the foreign countries. All right, so this is one of my pet peeves, a problem with databases, all databases. Most of your UAP reports are misidentifications. Sometimes they're hoaxes, although that's a smaller percentage. And a big one is insufficient data. The estimate, and I've got two here, 9% and 6% of that entire database, all of those databases you just saw, are basically not about UAPs. So take, for example, let's say we were looking for a red Corvette, and 19 of you give me the location outside there of a sports car. One of you gives me the location of a red Corvette. So I publish a paper that says we have 20 data points, and it seems like the most likely place we have red Corvettes are over here. How can I draw that conclusion? Only one of those data points was any good. Yet time after time, we see papers that are written about data that has not been filtered. How many of you saw the paper in one of Nature's main, I believe it's called Scientific Reports? It looked at the New Fork database, right? There's a big plus on that paper. The big plus is they got their paper in a very important journal. So for that, I highlight that paper and I say that's great to those authors. The downside, though, is that they looked at the 20 sports cars trying to find the red Corvette. And so you can't, and this is what I'm going to go through, you can't just look at data without filtering it first. So these are some examples on the top of cases where they've looked at all the data. And you can see on the right-hand side the type of object that they said was most common. You have everything from star-like objects, right, lights in the sky, to disks, to spheres, to crescents. If you look at the last one, the Arrow report of 2022, the sphere is what they identified as the most common object. But if you followed Arrow, you know that as they've indicated, as others have indicated, that the majority of their data are not true UAPs. So do I care that they find spheres? Were those balloons, or were those real UAP? That's my pet peeve when we look at data. Now, there is one report on that list which was filtered, and that was the Battelle report. And they came out with an elliptical object, or basically the disk shape. So this is what we decided to do. And now we did this manually. I would suggest the best way to do it is like through Doug's system, and try to do, as I go through this, think about, could we do this with AI or automated and not manually like we did it? Because doing it manually is not always the best way to do it, but it is a good way to do it. So in our analysis, we took the databases on the left, Project Blue Book, the French database from GIPON, NICAP, CUFOS, and MUFON. The key reasons we use those databases, for example, and not NUFORC, is because these cases have a much higher percentage of investigations, right? Because if a real UFO landed right out there, one person saw it, reported on it, but it was never investigated, how much value is in that report, right? So we had over 100,000 cases, and we distilled that down to 301 cases. What were we trying to do, you might ask? Basically this: we wanted cases where there was only one of two possibilities. This object is so close that it can't, misidentification is no longer an issue. So you have two possibilities. The witness saw it, or witnesses saw it, or they lied. That's it. You don't have to worry about all the others. So we went and looked for that, and then we said, what can we learn from those cases? So what were the criteria that we used? Because you're probably wondering, how in the heck could you guys go through 100,000 cases? Well, the first biggest filter was the UAP databases were screened and someone investigated. So out of those 100,000, if it wasn't investigated, then it was off the table. Then we applied these four criteria. We wanted the observations to be reliable. So that meant multiple witnesses or a single witness, such as a pilot or a policeman, someone who has to report to his superiors to what he said and what he saw, which makes it less likely you have a hoax, for example. Second criteria was the nearness of the object. Many of you have probably heard Hynek's criteria of 500 feet for an object, which works pretty good. But if the object is 2 inches in size, it's pretty small at 500 feet. If the object is a mile across, heck, it's good out to 2,000 or 3,000 feet. So instead of using raw size, we use angular size in the sky. So what we used was a value of 0.15 degrees. Why did we pick that? Well, it's somewhat subjective, but if you look at the moon is about 0.5 degrees in angular size in the sky. So what we're saying is, if the object was at least 1/3 the size of a full moon, then you should be able to see some level of detail, right? Because if you look at the full moon, you can see the craters. So if it has wings, you should be able to see those, for example. Third criteria was sufficient lighting. So that means we prejudice towards daytime sightings, right? So lights in the sky are off the table. The only nighttime sightings we use is if the object was either one, it was self-lit, or two, city lights, for example, lit the object. And the fourth criteria was sufficient detail and information. If the report that was done was of poor quality, then we did not use it, right? Because we can't gather scientific data on it if the characteristics of the object are not noted in the report. So these are some of the data that we collected. The shape, the approximate size, kinematics such as does it hover, approximate speed, acceleration, odd motions, EMI effects, sound or lack of sound, and effects on the environment. These criteria were also collected, which are temporal and location information, but these will be in our second paper. This paper is basically the characteristics of the object itself. We chose shape as the primary bucket to put these case reports into. So, and we took into consideration, and this is just something you have to realize, right? The viewing angle can change the shape. For example, if you take a disc and you look at it straight above you or straight below you, it is going to look like a circle or a sphere. If you look at, for example, a disk from the side, it potentially can look like a cigar. So that's one issue. Another issue is the nomenclature the witness uses. One witness might call a disk, and someone else might call it a sphere or a cigar. In a triangle, you might have someone call it a delta shape. So we take that into account. So of our 301 cases, this is how it fell out. The disk, or the elliptical shape, made up 36.5% of the sightings. So what does that mean? That means that we're going for cases where we are very confident the witness saw what he saw unless he lied. And so what we're seeing is that the disk is the most common shape throughout history. Second most common is the triangle. Third is the oval, which you could make a very good argument is part of the disk. And the fourth is the sphere, a little bit farther down the table than what you might have suspected if you had read the Aero report. All right, so I want to go through this a little bit. This is just a table where we look at shape and size. I'm going to skip through the disk and the triangle because I'm going to go into those more deeply in the next slides. But as you can see, we have 110 disk reports out of the 301. Triangle second at 33. Third was the oval. Fourth is the sphere. Now, something interesting about the sphere. Of all of the shapes that we identified, the sphere was the smallest. And it's usually in a 20 to 40-foot range, and sometimes some of the reports are even much less than 20 feet. So it gets the unique title of the smallest of these shapes that are seen. If you jump down to the two largest, it's the rectangle/diamond shape and the boomerang. Those, we had 6 of each, and the average size is usually around 300 feet. And to know how consistent that was, if you look at the boomerang, the average size and the median size were identical, both at 300 feet. So that indicates to you having repetitive numbers very close to each other. The other thing I want to note, just because it's popular in our minds today, is the tic-tac, which is sometimes called a lozenge. We had 8 reports out of 301. So that means we found 8 times where it was close enough that we were confident the witness could not have misidentified this object. And its size, again, is pretty consistent at 35 feet, about the size of a jet fighter. All right, so now I just want to go into the detail on the disk and the triangle. So what we did here is we identified these because we had a large enough number that we felt we could, put some meaningful size, shape, geometries to this. So with the disk, we had actually 3 types of disk. One was the disk with a dome on the top. That object is usually a ratio of 2.5 or 3 to 1. What do I mean by that? The diameter of, like if you had a plate, the diameter of the plate divided by the thickness of the plate, right? So if I say it's 3 to 1, then that means that this object was 30 feet across, then it's 10 feet in thickness. And then we also show that the average size of the dome with the disk with the dome is 20 to 40 feet. Now, we had 2 types of disks without a dome. And this is something we didn't really expect. And what really drives this is that ratio and the size. So if a disk does not have a dome, it is either small, very similar to the disk with the dome, 2.5 to 4 to 1 ratio, a size of 30 to 60 feet. But if the disk is really long, right, so a ratio of 7 to 1, or 5 to 1 to 10 to 1, but 7 to 1 was our average, the size diameter is 100 to 150 feet. So it's interesting that you see a specific relationship between that ratio and the size of these disks. Then you go to the triangles. Two types. One, the isosceles, which is the key component there, is that the base is roughly 1/2 of the length on this isosceles triangle. These varied a lot in size estimates, anywhere from 30 feet to 300. They usually have multicolored lights. A lot of witnesses describe them as Christmas trees, so all the colors. And there was no consistent pattern on how these necessarily showed up, other than they were isosceles triangle shapes. But the equilateral triangle, that is probably the most consistent shape and description of any of the UAPs. They're usually 100 to 150 feet on a side. So you're talking about basically the size of a 747 on each edge. That is a heck of a large object. And then there's a light at each vertex of the triangle, usually red. And there's often, not always, but often a smaller light in the very center of the triangle. And this pattern was very consistent. So we had our college students actually create us some drawings based on what I just told you. So this is the disk with the dome. 2.5 to 3 to 1 ratio, about 8 to 16 feet in height. So I guess I could stand in it. And 20 to 40, 50 feet across. Now the next slide is interesting. This is a drawing made in the Battelle report. The Battelle report is a report made for the United States Air Force based on the data collected during the Project Blue Book, Grudge, and Sign era. And Battelle, like I said, filtered their data. They took out the cases they didn't believe were real, and they did it manually, just like we did. And this is what they drew. Size, 20 feet, 6 to 8 feet high, which gives you a ratio of about 3 to 1. So it's interesting that we and Battelle come out with the same basic shape. This is the disk without the dome. Some reports where you read someone says it looked like a football or it looked oval. That could be that one also. 30 to 60 feet across, 10 to 20 feet high. And here's the big version of the disk. This is their 737, I guess, or 757, whichever one's the big two-story job. 100 to 150 feet across, 15 to 20 feet high. So the height is about the same, but it's much, much larger, and the ratio about 7 to 1. This is the isosceles triangle, and they just tried to show the Christmas tree light pattern that's often shown. And the equilateral triangle. These became more common in the 1970s, although they've been seen prior to that. And they probably peaked in the 1990s to the year 2000. But it's those two pictures you see are very consistent with what almost everyone reports if they report an equilateral triangle. This looks very similar to what Micah talked about in his story a little bit earlier today. All right, so these different shapes, what was unique about them? Let's start with the disk. Most of the disks were able to hover, and most had extreme acceleration. So in our paper, we threw speed into several buckets, like basically hovering to the speed of like a Piper Cub, to the speed of commercial aircraft, to jet speed, to missile speed, to speeds greater than 4,000 miles an hour, which means you're looking at greater than Mach 6. And extreme acceleration is the greater than Mach 6 type of speed. So the disks were having that capability. They're capable of hovering and extreme acceleration. The wobble, many of you who have studied this subject for a number of years know that sometimes people describe a disk as it moves as like a falling leaf as it just wobbles down. If you saw some of the science fiction shows of the 1950s, you may have, sometimes that is even imitated. They also spin. And for sound, there is either no sound or a slight hum is the most common notations on sound. And they have EM interference with disks. Not every time, but that is not unusual to have EM interference when a disk is involved. Now, one thing I want to mention on sound. When we say no sound, it's not like the witness says, I didn't hear anything. It's more like the witness says, I should have heard something. I don't know why I didn't hear anything, but this thing was totally silent, right? So it tells you something. That's different from just saying, I didn't hear anything, right? The witness is making a specific point that he knew he should have, or she knew they should have heard something, but did not hear anything. And I'm going to jump to the oval, and you'll see, if you look at the oval, it's very similar to the disk. So that's probably potentially the same population. One difference is there are oval reports that indicate loud noise, which might be unique to a particular part of the oval group. Triangle. This is something we did not expect to learn, or at least I didn't, when we did this. And I have studied the UAP UFO subject for 17 years, and this just never hit me until we did this report. And that is, of the triangle, 32 out of 33 reported not only hovering, but extreme acceleration. So we're talking about an object that's hovering and can disappear from your sight within 2 to 3 seconds. And think about that. If you're at a jet air show, a jet which is not hovering, he's coming at his full speed, goes past you, and it's 12 to 13 seconds before he disappears. Well, these objects, the witness says they did it from a standstill in 2 to 3 seconds. The other thing that was interesting about the triangle that had not dawned on me, and that is we had no triangle reports of EM interference. And it's just something that I'd never thought about. I mean, that is a fairly common thing that happens on a by fairly common, I mean, it's not unusual to have EM interference. Yet the triangle has never initiated EM interference. Now, that doesn't mean there's not a triangular case out there with EM interference. But what we're saying is of these 301 that we identified, we had none with EM interference. So on a quick discussion, up until our report, the Battelle report was the only historical shape study where selection and filtering of reports was undertaken. So what I'd like to suggest here is that anyone who studies UAP reports should filter the data first, unless the purpose of your study is just to see how does the population do reports, right? Then it would be legitimate to do that because you're just looking at, oh, here's where people come from that do reports. But if you're interested in the UAP and not the person making the report, then those reports should be filtered. One method that can be used, so you don't have to manually do it, is natural language processing, right? I won't go into the detail of that, but it's basically using computer algorithms to make a determination of the likelihood of a report being strong or weak based on the language that the witness uses in making the report. And then you can also use AI. So I think it would really be interesting to try to duplicate this, for example, using the system Doug is developing and using it totally with AI and see what the AI comes with. Now, it's a challenge, right? Because think of one of the criteria, that we have a certain angular degree size. We did that using humans, so your AI has to be able to figure out from the text, was this an angular size, of at least 0.15 degrees by comparing distances and comparing size of the object, et cetera. One thing we could also use is use this type of information for AI programs that look at satellite systems, right? And tell the AI, this is the size ratio that we're looking for. See if you find any objects that are a 7-to-1 ratio that are between 100 and 150 feet in diameter. And the last one is optimizing synthetic aperture radar, using that to identify objects from space. But there are some problems with that, but I just wanted to mention it. Conclusions. The disk is the most frequent UAP shape. I'm convinced there is no shape that is more common than the disk. And the approximate sizes vary from 30 feet to as much as 150 feet in diameter. And that is usually, part of that is the ratio that controls, apparently, the size of those disks. And then the triangle, which is the second most common UAP shape, which is interesting because, and we'll look at this in our next paper, if you go through time, like a timeline, that was not always the second most common shape, but today it is. So across time, something changed that made the triangle the second most common shape. EM interference was never reported on a triangle. And then this last point I think is very important. When you're looking at, is there a terrestrial explanation? If you're confident that an object was hovering and then suddenly accelerated, right, to a high speed and then hovered again, that is very difficult to explain with any terrestrial object. For example, the F-35 can hover for a short period of time if he doesn't use up his fuel, and he can then begin to accelerate and then could begin to hover again, but he's definitely not going to be silent. So you would definitely hear that going on. And these were the number of times we saw that, where you have an object that is hovering and also has the capability of extreme acceleration or traveling faster than Mach 1. The disk with the dome, we saw that once. A disk without a dome, 4 times. The triangle, 8 times, going from a hovering position to speeds greater than Mach 1. And some of these were well beyond, were like Machs 5 and 6 based on the witness testimony. But think about that. You're talking about an object, each size is the size of a 747 that's capable of just sitting in the sky and doing nothing, and then suddenly accelerating. So you're left with this choice. Either the witnesses have just lost their mind or are lying, or it happened. And you cannot, I know we can have black projects, but science develops slowly. We build brick by brick to get to points. You don't suddenly go from where we're at today with the capability of putting a large object in the sky and then suddenly accelerating. Plus, having characteristics such as Micah mentioned, where it just turns upside down, or a math professor that I interviewed, he saw this same equilateral triangle spin as it moved off. So these are non-aerodynamic qualities that you don't see in terrestrial aircraft. So I would like to acknowledge on this paper Ike Okafor, who at the University of Toronto got those students for us, and the University of Toronto paid their work as they worked for us. And also, if you're interested to go into detail on the study and see the cases we used, on this site you can see the Zenodo link. It's also, this paper also has that link on the SCU website. And you can actually download the 301 cases we used, the full report. So you can read each of those and make your own opinion is what you think about those cases. And that's all I have. I hope I didn't go too long, Micah.
Not at all. That was excellent. Thank you for that very comprehensive overview, Robert Powell. And again, I mean, I'm just amazed at how much data there is that really, when you go back with fresh eyes and you look at the accumulation of historical data over time, there's so much information that comes out. And we're already getting some really great questions, too, in the Q&A, which we'll get back to here in a bit. Right now, why don't we move on to joining us remotely, Ian Porritt. Now, Ian, of course, has been working with Larry Hancock on this intentions study and trying to, again, to understand not only where objects occur, where they have happened, when they have occurred, but also what this might indicate, what the proximity, for instance, to atomic warfare complex sites this could indicate about the operations and intentions of the craft and perhaps their operators. So that is really kind of the crux of what these two have been doing. We'll now go to Ian Porritt and feature his contribution here for the panel remotely.
Thank you for the opportunity to present our study to you today. My name is Ian, and I'll be covering the work our team has done over the last several years on understanding the patterns and the intentions behind the UAP phenomena in the US during the 1940s to the 1970s. The breadth of the UAP phenomena is daunting, and the question around intentions is even more so. Our team has been applying the practices of pattern recognition and indications analysis to the questions of UAP intelligence and their intentions. Those practices have been incorporated into a model which presents a structured methodology for the study and assessment of UAP intent in a variety of domains. This presentation will provide an overview of the intention study model and its applications to the US military and public activities. Each group of our studies are broken down into these two separate parts. The first part is a pattern recognition study, where we collect the incidents and analyze the activities, which is the bottom of the pyramid. The second study, the indications analysis, builds on the first paper. We define the intention scenarios, map each indicator to each scenario to come up with our best estimate of the likely intention of the UAP. To summarize the studies, there are 2 focus areas and 4 studies in our series. All 4 studies focus on the United States and during the period between 1945 to 1975. The first focus area is the US military complex, and the first paper found an intelligent, focused activity around the US atomic warfare complex. The second paper, the indications analysis, found that this pattern was most likely to be an advanced military capability survey of the atomic warfare complex. The second focus area is around specific UAP activities in both the public and military domains. The third paper found a transition of UAP behaviours where their activity shifted from highly visible, daylight and at a distance incidents to public close approaches and at night. And the fourth paper is still a work in progress. For all the studies, we have established a collections framework, what sources will be used, what data we need to collect, and what criteria will be used to select appropriate incidents. In terms of the sources used, the main sources were the Sparks and the NICAP catalogues. We then go through each source and build a separate study database in which the analysis will be based. A reconciliation process is then done to ensure each incident meets the collection framework. A number of incidents are reported in both data sources, so to ensure there was no duplication incidents used in our study, we also reconcile each incident against both sources to ensure we don't double count any incident. When each study is published, we also include a database of the incidents we have used, which links back to the source. For the 4 studies, there is a common set of incidents, and over the 4 studies, we've used over 1,000 incidents. Each study has its own defined selection requirement, and only incidents that meet the requirement are included in the study. Individual incidents can be included in both focus areas if they meet the study criteria. Now we'll look at Study 1 in a bit more detail. Study 1 was a UAP pattern recognition study, 1945 to 1975, for the US military atomic warfare complex and was published in April 2023. When we compare the reports at the atomic warfare sites against the reports at the standard military sites, we can see that there is a significant higher interest in the atomic sites, and that this interest by the UAP was during the key periods of development. The period 1947 to 1951, which was the establishment of the radioactive material production plants at Hanford and at Oak Ridge, and the 2 atomic weapons assembly sites at Los Alamos and Sandia, the storage of weapons at the SAC bases, and the testing of missiles at White Sands. This was a key point in time in the development of the atomic warfare complex, and these key sites during these key times were the sites targeted by UAP. The period 1965 to 1967 at the newly established Minuteman II ICBM sites was another key point in time for the delivery of atomic warheads, and these ICBM sites received focused activity by the UAP. 1975 saw another focused cluster of activity by UAP at their newly established Minuteman III ICBM sites. So we have a significant elevated interest at the atomic warfare sites, and this elevated interest occurred at strategic times during the atomic warfare development. During 1952 and 1957, we see a wider US peak of UAP activity, and during these peaks, we see a much wider interest across a larger number of both standard and atomic military sites. As mentioned, a few key sites during the key phases of the facility establishment reported the majority of UAP reports for the military. The top chart shows a cluster of activity at the radioactive materials production plants of Hanford and Oak Ridge, and the 2 atomic weapons assembly sites of Los Alamos and Sandia, and the SAC base of Killeen. The middle chart shows a cluster of activity at the missile site of White Sands, and the 2 clusters of activity at the ICBM sites. This is a targeted pattern of activity and therefore intelligently focused and focused on the US atomic warfare complex. Note, in 1952, when there was a wave of UAP activity across the US for both the public and the military, a wide range of standard military sites did report UAPs. They were capable of observing and reporting UAPs during this wave, but the lack of reporting from standard military sites prior to this suggests that they were not the focus in the prior years. When we plot out the locations of the individual military sites, we can see the military facility types were spread across the US. The UAP incidents were not geographically focused. It wasn't targeted at a specific area. It was targeted at military facility types and at their critical moments in history. This was not a geographically focused survey. It was a facility type survey. Study 2 was a UAP intentions analysis for the US atomic military warfare complex and was published in August 2023. From the pattern study, we established 31 indicators covering these 20 areas, which we used to map to the various scenarios. For Study 2, we also included several other non-site-specific reports relating to the military in order to understand the wider military context, such as bomber alert missions and air defense exercises. We also looked at non-military reports around nuclear power plants. We then took our 4 scenarios, which are a general military survey, an atomic weapons survey, atomic warfare prevention, and the last one, military aggression by the UAP. We then created a matrix of indicators and scenarios. Each of the 31 indicators is assessed for its data quality. Are we able to make an informed decision based on the data? We then determine if the data supports the indicator pattern. We then take each indicator and assess how much that indicator supports each of the 4 scenarios. This matrix forms the basis for the decision within the group and is used in combination with the individual detailed reports and the pattern analysis to inform the estimate of the situation. Based on our assessment, we then rank each scenario from the most likely to the least likely, with the atomic weapons survey ranking first, followed by a military survey, an atomic warfare prevention, and lastly, military aggression. Study 3 was published in March 2024 and is the activities pattern study of the US military and public UAP reports. For Study 3, we focus on 9 UAP activities. These activities suggest forms of display, interaction, or contact. They were interactive flight, so UAPs flying in formational groups, radical flight, displaying technologies in advance of current technology, loitering, being able to be observed for long periods of time, electronic transmissions, interference with weapon systems or intrusions, close approaches and occupants being observed or encountered. So previously we focused on the location of incidents. Here we focus on the type of incident. These 9 activities were then plotted out to see the trend over time. From the pattern analysis, we are seeing a number of patterns emerge. Starting at the top of the chart, interactive flight, radical flight, and loitering are relatively high to begin with and decreased to very low levels by 1975. Electronic transmissions, predominantly IFF, which is a coded transmission being received from the UAP, is clustered in the middle, and interference with weapon systems and intrusions are small in overall numbers, but their occurrence aligns with key atomic warfare patterns identified in Study 1. At the bottom of the chart, close approaches to the public, occupants observed, increased to relatively high levels in the two peaks in the 1960s and 70s. We also classify the incidents used in the study as relating to the military or the public, and if the incident occurred during the day or the night. There are two noticeable patterns here. One, an increase of public incidents started early 1960s, and for both the military and public, a move from more daytime incidents to predominantly nighttime incidents. We then put this all together to show the transition over time. There are three broad phases over the study period. 1945 to 1954, which is defined by daytime incidents involving interactive flight and radical flight. These are highly visible displays of advanced technology. 1955 to 1964, we start to see a transition away from display type activity, more nighttime activity involving close approaches and a cluster of IFF transmissions. Lastly, from 1965 to 1975, we see predominantly nighttime activity directed towards the public and close approaches. While running through the whole study period is military interference and intrusions occurring at key strategic times of the development and deployment of atomic weapons. Even though we are looking at activities rather than locations of report, we also plotted out the locations and the date of the reports within the US. Interestingly, with the increase in nighttime public approaches, we see a cluster of incidents during 1970 to 1974 in what is described as the US Rust Belt, the industrial area of the US. With the following year, 1975, where there is an increase in activity at the northern atomic military sites, the public encounters drop off around this location. Following on from Study 3, we are currently working on Study 4, which is covering the possible UAP intentions related to the patterns of activity found in Paper 3. This study will hopefully get published towards the end of the year. Similar to what we did with the intention study for the military facilities, we will take a number of possible intention scenarios involving various stages of contact protocols, human behavior studies, exploitation and assistance, and apply the activity indicators to understand which of these scenarios is the most likely. An interesting complication is the change in observations over the study period. There are a number of tools we use to assess each scenario. Here we look at two factors: the degree of overtness on the y-axis and our perception of the interaction from negative, neutral, or positive on the x-axis. With all the intention scenarios, we should see a progression from the bottom middle, that being a more clandestine and a neutral observant perception. The reason for this is, given an unknown situation, the prudent thing to do would be to gather information first. This early progression is prior to our study period and could be short or long in duration. As they gain an understanding of their operational environment and progress their operation, we should start to see a greater level of interaction, either positive or negative. In careful analysis of the interaction, we should start to see the early signs of their intention. What we see in our study is that the UAP incidents predominantly sit in the more neutral middle section, but the direction of change is interesting and important. If we look at each individual indicator, both in terms of where they sit on the chart and when they were occurring, we see that the early UAP incidents involving aircraft engagement, aircraft encounters, daytime visibility, interactive flight, radical flight and loitering, the green boxes, are more overt and slightly more positive. As we move through to the incidents post-1965, the red boxes, they are both less overt and occurring mainly at night. Interference and intrusions at military facilities occur throughout the study period, but at low levels. We are still working through the process of understanding the intention scenarios from Study 3. We see a movement from a more overt, highly visible and display type activities to slightly more nighttime activity involving close approaches to the public. We see a reverting of their interaction rather than a continuation, suggesting a pause or rethink of their intention. Interestingly, during this transition there is a cluster of IFF, coded friend or foe transmissions by the UAP. Was this an attempt at communication? Was this reverting a response to our reaction to them, or our lack of positive response to their attempt at communication? Is our level of technology combined with our level of aggression a concern to them, either operationally or in terms of interaction? These are the questions we are working through in our fourth paper in our series on intentions, which is on track for publication toward the end of the year.
Another excellent presentation there. Ian Porritt, who was our primary speaker, but of course it's important to emphasize Larry Hancock also was the co-author of both of those, actually all of those studies. I think the fourth paper now, right. He was the project leader on that, and of course that fourth paper is now on the way as well. So also on that note, since we've got our primary panelists here speaking about their respective projects and areas of focus, being remote as they are, Larry and Ian will be on hand via the Whova app. They will be interacting digitally. So if people have questions, you may be able to put those into the chat. And Ian and Larry, that's one way that they can interact and they can actually answer some of those. At this point, Gary, we'd like to come over to you. Gary Stephenson.
Sure, thanks, Micah. And thank you, Peter, for inviting me here today to present what we've been doing on the means and methods of propulsion under the guidance of Tim Oliver with Detlef Hoyer and others on the Propulsion Committee. I don't see the briefing yet.
Yeah, they'll get it up here.
Oh, here we go. Yeah, so this is actually of general interest to the overall academic community. This has been accepted for briefing at Marcel Grossman. They're very interested in what we're doing. And so has Detlef Hoyer's work on the committee with five-dimensional Kaluza-Klein solutions to the Einstein field equations, extensions to the Einstein field equations. What we've been trying to do is look at possible general relativity solutions that could account for some of the behavior we're seeing in UAPs. So what we're doing is presenting broad categories of potential solutions for propulsion stemming from the use of general relativity or quantum mechanical effects that can change gravity. So the two broad categories I'm going to be covering here are the classical general relativity solutions and quantum mechanical solutions that can affect gravity. One of the ones I'm most familiar with, and the order this is really from what I'm familiar with to what I'm not at all familiar with. I've published a couple of times on forward coils. Robert Forward was a contemporary of mine at Hughes Aircraft Company. He researched gravity and lasers at Hughes Research Labs in Malibu. At the same time, I was down in El Segundo working for Hughes. One of the things he invented was the mass flow toroid, called a forward coil. That if you flow mass around up the center of a coil and down the outer edge, and you flow enough mass fast enough, you can get a frame dragging effect that's additive in the middle and subtractive on the outside. And so if you have a way to collect it in the middle and then, for instance, run it through a high index material, you can get a concentration of gravitational acceleration in the middle of this. And it can become, it's a DC device, it can become a thruster of sorts. Interesting aspects of this is it's very low EMI because the vast majority of the magnetic field is captured inside the body of the toroid. And so you don't see any EMI with this. So for instance, this would be a good candidate for the triangular shaped craft because one of the aspects is very low EMI. There is a lot of mass flow, and if you're pushing at relativistic speeds where the electrons, for instance, you might be flowing in nanowires, superconducting nanowires, might be getting near relativistic speeds, that could result in Bremsstrahlung radiation, which could be emitted down the middle of this thing. So you may actually see a glow coming out of the middle of these, which if you had one in each corner of a triangle, could certainly result in the same kind of signatures we see in the triangle craft. Another possibility is the use of gravitational waves. One way to make gravitational waves is a plasma quadrifold flow. This is using, for instance, a tokamak fusion reactor, the plasma of a tokamak fusion reactor, and modulating that plasma flow so that it results in a quadrupole moment. To make a gravitational wave, you need a third derivative of a quadrupole, and it goes as the square of that third derivative. So if you're mashing flow back and forth in a quadrupole manner, in modulating it in a plasma flow, that plasma flow will result in a gravitational wave. Now, a gravitational wave by itself is not useful for propulsion. You have to find a way to rectify it, to turn it into a DC kind of field. And one way to do that is quadrupole rectification. What you do under this scenario is you squeeze it one way very quickly, and you release it very slowly in the opposite direction, so that on one axis it's very strong, on the other axis it's very weak. Since it goes as the square of the third derivative, that enhances the direction in one direction, and it minimizes in the other direction, and it creates a sort of nonlinear imbalanced force. And if you arrange, as you might see, it's hard to spot in the lower right. If you arrange a couple of these quadrupole flow generators, you can send negative going pulses to a forward reaction mass in a craft and positive going pulses to the aft reaction mass and have a forward momentum imparted. This would be a good candidate for something, for instance, if we observed a UAP with a SIGINT aircraft and the signals intelligence showed a large EMI in the microwave field, not that that would ever happen, but a scenario like that would point to a kind of craft that may be using a gravitational wave propulsion like this. This was first predicted by Grishchuk and Sajin in Russia in the 70s, and I've published a couple times of it, the last being at a high-frequency gravity wave conference in China in 2017. There are other ways to create gravitational waves. There's a way called the Gertzenstein effect, in which you pass an electromagnetic wave through a strong gravitational field, and it's a synchroresonance effect in general relativity that results in a gravitational wave being emitted. There's a couple different ways to do that. Boccialetti created another scheme using general relativity equations where you can use either a static E field or B field. And so those are other ways to create gravitational waves. There are also other ways to rectify gravitational waves. There's, because of the nature, because of the stiffness of space-time, there is a researcher called Christodoulou. There's an effect after him called the Christodoulou effect that says if you pass a gravitational wave through a pair of test masses, there's a permanent displacement between those test masses after the waves compared with before the waves. And depending upon the orientation of those test masses, you have forward propelled in a relative way one of the test masses with respect to the other, thereby imparting a momentum in a relative sense. So this is another potential way to rectify gravitational waves. Another scheme is your classic warp drives. Alcubierre is the most common and the most well-known. That's pictured on the lower left. On the lower right is a more commonly used solution now, the Narita warp drive, and there are many. I have many references using the Narita warp drive here. It uses a lot less energy. It's a lot more efficient, and there are every day more warp drive solutions, including just this month, drawn to my attention. Thank you, Glenn Robertson, for drawing to my attention the Fuchs 2024 Fuchs paper. He's a local here at University of Huntsville. University of Alabama at Huntsville, and that was just put on archive on May 4th. So there's a new warp drive every day. It's fascinating to see how rapidly these solutions are evolving. Just to point out, before I go to the next slide, the difference between a warp drive and a wormhole. A warp drive, you'll notice, is still a surface. So it's topologically, it's an S0 surface. If we go to a wormhole, it's topologically an S1 surface. It means it has a donut hole. And so it has this throat that conjoins two different pieces of space-time. Both of these are static in the sense that they perpetuate in time. They're not instantaneous. They continue for a given amount of time. So long as you keep putting energy into them, they keep existing. The first solid general relativity wormhole solution I saw was Kip Thorne's along with Morris in '88. Matt Visser did one in '95. Eric Davis proposed one for inducing propulsion in '98. And there have been follow-ons to that. Traversable wormholes in 4D is the most common in 2022. So I will have a list of all of these references when I develop a companion paper for this for Marcel Grossman, the General Relativity Conference coming up in July. So a special solution for warp drives that Matt Visser had a lot of fun with a couple of years ago. He and his contemporaries put together a series of tractor beams, and you'll see the alien here with the cow. You can use a tractor beam to pull the cow towards the spaceship, or you can use a pressor beam to push him away, or a stressor beam to maybe slice and dice them and take a biological sample. So it all depends upon the relative location of where you put the push, the bulge, or the dip in space-time. If you're pushing the cow away, you put a dip in front of him. You put the surge in front of him. You put the dip in front of him if you want it attracted to you, and so on. So these are really special cases of warp drives. Now we switch gears. I've been talking about classical general relativity using Einstein's field equations. This is a very different beast. The problem with using classical relativity is when you look at the Einstein field equations, the coupling between mass and energy on one side and the warp you're going to get in space-time on the other side is g over c to the fifth. The c is the speed of light, and you take that to the fifth power and you put it in the denominator. That's terrible coupling. So how do we improve this coupling? One way to do that is quantum mechanically. And so in 1964, a pair of authors, Halperin and Laurent, looked at quantum transitions that could force a graviton to be emitted instead of a photon. Now, we haven't been looking for these emissions, so we haven't seen them. But you need the instrumentation in order to make the measurements, right? So one idea is have a parajunction, a solid-state junction, that forces these graviton transitions. These are spin 2 transitions. Is there a way to stimulate those transitions with photons, with an electron flow that would normally activate photon flow, but have a junction, for instance, a type 1 to type 2 superconducting junction that disallows photon emission, but does allow graviton emission? That was Fontana's idea using the work of Halperin and Laurent. And he named it the Gazer for a gravitational laser, essentially. And he's published on this extensively. I believe it was in one of Glenn Robertson's books. He last published this notion. He's published it at STAFE, Space Technology Applications International Forum, and in other venues. He's described it at the high-frequency gravitational wave workshops that we've held with the Russians and Chinese. So he has published this on many different occasions. And the idea are these type 1 to type 2 Josephson junction kind of connections, which you'll see the transitions pictured on the left, and then the type of junction that could potentially be stimulated to emit these gravitons on the right. So we're categorizing this as a quantum mechanical gravitational emission. So that's our first quantum mechanical case study. And so this, for instance, would be another one where we might see, a lot of EMI, because to stimulate these emissions, there's going to be a lot of electron flow to stimulate this kind of graviton. More to the point, there are metamaterials that have a sub-index of 1, an index of refraction less than 1. And what does that do for you? That gives you, instead of a red shift, that gives you a blue shift, which could potentially be viewed as a repulsive gravity versus an attractive gravity. And why do we think this is important? Well, the two things that are important about it, number one is you get propulsion out of this because you can manipulate your light cone. And so that's pictured in the middle. Manipulating your light cone is shaping the space-time, the way that space and time is interacting with your craft. You're shaping space-time around your craft due to the metamaterial skin of your craft. Jack Sarfati, a researcher that has been off and on engaged with government organizations to work the theoretical details of this out, will argue that this is the best possible explanation for the tic-tac propulsion. And why does he say that? It's because our sensors, when we look at a tic-tac, when we're looking at the infrared of a tic-tac, it looks cold, it looks dark. But when we visually see it, it looks like it's glowing white. So his theory is we're blue shifting black body radiation, which is what an infrared sensor would see. We're blue shifting that out of the infrared into the visible. And so that would account for the signature of these tic-tacs. And so this right now is a leading candidate for describing how tic-tacs operate. I want to be complete, so this is something I don't know anything about. So some of this stuff is a little bit taboo. So I would recommend that you take Julia Mossbridge's recommendation and break out the universal love and wrap yourself in that to protect yourself from any fear of some of these teleportation techniques. What's the difference between a teleportation and a wormhole? The difference is a wormhole and a warp drive are persistent. Teleportation events are, if not instantaneous, very rapid and very temporary. And so a teleportation scheme has been thought up with Morris and Thornigan and with Matt Visser. And Hal Puthoff looked also at this. It's vacuum metric engineering. It's polarizing the vacuum by shrinking or growing how many vacuum states there are inside the vacuum. The most classic version of this is the Casimir effect, which points out that the two plates are being pushed together because we're reducing the allowable vacuum modulations or vacuum fluctuations in the vacuum metric. And so this could be imagined that if you could control the vacuum metric, if you control those modes that are allowed and not allowed, you could very temporarily and almost instantaneously shape the space-time around you so that you're pushed somewhere else very quickly. And so this is certainly another candidate and would fit the profile of a craft that is very rapidly moving from one space to another without, for instance, disturbing the air. There's another notion called quantum entanglement, where you're transmitting instantaneously from one spot to another quantum information. So for instance, Eric Davis did these drawings in the middle and lower right to describe the difference between a regular fax machine and a quantum entanglement fax machine. The quantum entanglement reads your quantum states as it's destroying your body. It maintains that information, and with its quantum entangled partner, will 3D print those quantum states at the quantum level right back out to wherever the receiving station is. And that is, in a sense, teleportation. You're transmitting instantaneously through quantum entanglement all the data in your body. And so this is certainly one potential way that a teleporter could work and was featured in Business Insider. When I make these slides available, you'll be able to use these live links in the slide presentation. Another way, and there's very little empirical evidence for extra dimensions, but I wanted to mention this because there have been a number of papers in the past talking about hyperspace. Is there a way to shift to extra dimensions and go into or out of those extra dimensions? Certainly 5D Kluser-Klein, like my associate Detlef Hoyer has described, would be one way to leverage extra dimensions to travel through space-time, because we're using those extra dimensions to alter our space-time metric in our dimension. And so there have been a number of attempts at this. Green did them, Randall and Sundstrom, and I can make these references available when I publish the companion paper. And so why do we think this will work? Because we have actually already observed it. And I heard yesterday a presenter say we don't have any evidence for interdimensional beings. That's not completely true. We have run across one race that has the capability of interdimensional travel and interdimensional manipulation, and that's us. Us human beings have been witnessed to have psychic and telekinetic teleportation abilities, granted in a very, very tiny sliver of the population, but it really defies prosaic explanation. What we've seen in published reports from Russia, and especially from PRC China, is that they're very scientific, controlled experiments where we have two different boxes, an object's placed in one box, both boxes are sealed, both boxes are subjected to high-speed cameras, and the object disappears from one box and reappears in the other box, a physical object. Sometimes it disappears and is gone for a few seconds, just completely gone, and then appears in the other box. Sometimes, depending upon the test subject, it starts looking like it's dissolving and becoming translucent, and then slowly reintegrates in the other box. We have no idea how this works, but obviously people have the ability to do this. So that's been pretty fascinating. These are not exactly open source articles. These are articles that were published in foreign language journals that were translated by a defense intelligence agency. So the chain of custody here on these references are, as they were published in their own native tongue, they were found material by DIA, translated by a defense intelligence agency, wound up in the hands of Eric Davis. Eric Davis published most of these in a comparative paper he did on telekinetic teleportation about 20 years ago now. So this has been out for about 20 years, but because it's taboo, or has been taboo until universal love took over, this hasn't been talked about a lot. So I wanted to, this is the last version I have. This is the last kind of teleportation I have because it's the least understood, certainly by me. But I wanted to include it for completeness. There is a new emerging field called neuroquantology. It's not ripe yet. A lot of the papers don't have the kind of academic backing you would expect from scientific papers. But I also wanted to mention it because it's worth paying attention to. It's not worth ignoring, and we should continue to track this activity. So that's it in a nutshell, a variety of classical and quantum approaches to gravitational field propulsion. We're looking, the next step of this is to quantify exactly what kind of signatures come out of each type of these gravitational propulsion techniques so that we can try to compare our experiences and the data that the sensors are picking up with these kinds of propulsion techniques to try to glean any more information we can out of these encounters. So that's the next steps. Thank you for your time.
Excellent overview there, Gary Stephenson. Thank you very much. Yeah, I'll take that. We're right on time. I think we've got just about 20 minutes for some questions. There are a lot of them that are populating right now here on the Whova app. I'm going to try and delineate these to their proper locations, respective of our speakers here, although some of them do not name any one individual. So if you want to chime in and I call somebody else, you feel free to take a lifeline or pass that along or bounce it over to one of your colleagues here. Let's start, since we just heard from you, Gary. I have an interesting question here about general relativistic propulsion. Have any of the gravitational wave generation schemes ever been to any degree constructed and tested?
Yeah, I know that's ongoing work, and I don't think there's been any published reports yet on any complete successes, because in order to know that your gravitational generator is working, you need a gravitational detector and receiver, right? And so you really need to do it as a pair, as a duplex signal. And so that's been the hang up, is matching that gravitational wave generator with the companion receiver. So no, not to my knowledge, not yet at least.
Yeah, I'm really interested in this neuroquantology too. We might have to come back around to that one. There's some extraordinary stuff. I think what some in the past called edge or innovative science there. Robert, this next one, coming over to you and that exhaustive analysis that you guys did with so much data over so many years. The questioner here, John, asks if the shapes or the non-shapes in some of those instances, and their sizes could be indicative of function and mission types. Like, for example, these may represent what we would call scout craft versus transport craft, etc. And also, may they actually represent command and control functions, or maybe even collaboration and coordination models. He says, get back to behavioral function and mission analysis. How might these areas be explored based on that data?
On that question, that would take a lot of speculation on my part. I mean, there's just no way I can know that level of detail just by looking at their external characteristics. The one thing I'll say, and this is speculation, but just not as wide range of speculation, is that if I had to bet money, I would say that these various shapes are not all from the same origin. So I would suspect multiple origins.
Excellent response.
Chevys, Fords, and
Yeah, exactly, right, yeah. Well, I mean, that's an important allusion to make. You look at the highway. We don't just have a single kind of car. We've got all different kinds of makes and models. We've got all different kinds of services and different functions that different kinds of automobiles and other kinds of vehicles, aerial, watercraft, et cetera, perform. So, I mean, certainly the same could apply to UAP. Sticking with that topic just for a second, I'll again do a callback to that account that the military officer shared with me. And those who may not have been here early enough, it was a large triangular craft that was observed over a long duration of time. But there was a small spherical reddish illuminated object that emerges from this craft while exhibiting these unusual, characteristics. And this smaller craft conducts sort of a survey kind of a thing, what he likened to a grid search. Now, this question, Robert, this would be best directed toward you. The questioner says, it's interesting that those spherical-shaped objects are the smallest. And so they ask, has anyone done a statistical study on secondary objects deployed from the primary unidentified object to see if the most secondary deployed objects are spherical? In other words, if this proves to be the case, maybe the spherical-shaped objects, and presumably those smaller ones, could represent some type of mini probes deployed from main UAP. I realize there's some speculation involved again here, but maybe you could at least speak to that point.
Yes, I mean, I can say that I am not aware of anyone who's done a study on that. And you could do a study on that, I mean, because there are cases where there are multiple objects involved in the sighting. So that, using, for example, the database project, once that's completed, that would be a way to do it. One thing I also wanted to comment, Micah, is the example you gave, where there was the red light coming out of the equilateral-shaped triangle. That same instance was reported during the Belgium wave by 2 Belgian police officers that observed an equilateral triangle. So, to me, that's always interesting, right, to have 2 strange reports like that from different points in time, and they're both so strange, you wonder how could both occur, unless perhaps it was real. Either that or the guy you knew read the Belgium wave story and decided to add that in, right? But short of that, it would be a heck of a coincidence to make that kind of a description of a triangle that drops out a red ball that goes out and surveys the area.
Yeah, in fact, some colleagues and I over lunch were looking at some intriguing photographs that seem to be suggestive of secondary luminous objects in relation to these large triangles. Peter, I want to come over to you on this next one. With multiple new smartphone apps for reporting UAPs, is there any training program that we might see that could help civilians to reduce the kind of junk that's going into, for instance, databases like the current one that the SCU is building?
Are there any training programs?
Yeah, in other words, ways that we can help to kind of refine that data before it goes into the database.
Well, I'm not aware of any. Certainly, we're not doing that. I'm not really aware of anything like that. But one possibility would be having a phone app, and we've looked into this. But I mean, it's difficult. But a phone app that would automatically do this for people. Your cell phones have an amazing amount of capability for analyzing things, gravity, electromagnetism. It could automatically, you could imagine an app that if there was something in the sky, you just pointed your phone at it and started the app, and it would set your camera automatically to the most optimal projection and angle it was at, and you can actually measure the angle. There's things called inclinometers that are built in there, the angle, and it can't get distance, but if it was near some known object, you could find out pretty much the three-dimensional space. But the other thing too would be if you had a network of these, if people had these, once somebody saw something, it could alert the other phones and let the people who had these point to the opposite direction for the people that are in that area, and would vastly improve. It's an inexpensive, well, it's a much simpler way to get better data on things, which could be something for the future, of doing this. So.
There are certainly some nascent developments in apps, and again, some that are currently being developed or are actually already in the testing phase, some actually being deployed that seem to, again, what we would need would be triangulation so we can gauge certain degrees of
if you can get two of them, you can,
Right.
if you get two of them and you know the approximate size of the object or you know the distance to the object, then you can get a three-dimensional, you know the distance between the two things. That's a GPS will tell you that.
Yeah.
So that would be a terrific improvement in our collecting data.
App developers out there who may be listening at home or here present, again, opportunities abound. So.
I actually contacted a company that makes this physics toolbox. It's an Android, free Android, and there's other ones that it doesn't do that, but it has all of these measurements built into it. And I figured, well, if you could combine that with a camera, this would be a really big advance, to stuff. But they're a small company, and they didn't want to get involved.
Unfortunate. Let's hope somebody will. I believe the authors of our intentions study are also available, and so I'd like to actually direct a question to them. With regard to the intentions study, the question is, were there sociological factors taken into consideration, such as, for instance, the Condon report coinciding with a decrease of military sightings in late 1960s? Also, a change to later bedtime starting in the 1960s might naturally lead to more nighttime sightings. So were certain cultural or sociological factors also considered?
I'll take that one. Since Ian did the presentation, I volunteered to do the questions and answers. The bottom line is we're taking sociological and cultural factors into consideration in the public studies that we're doing now, not generic, in terms of activities and what's being observed and how it's being interpreted. We did not try to essentially shape the data by looking at in cultural context in general, in terms of the Cold War. For example, what was the focus of the public dialogue in a given decade, a given year, the Condon report, the issuance of termination of the Blue Book project. So we talked about that beginning and actually prepared some extensive list of activities that we might overlay on it, and decided we would rather just stick with the reports themselves and not try to finesse them. So no, we have not done any interpretation in that regard.
Excellent. Also good to see you, Larry. Glad you could join us remotely here today. Sticking with that for a moment, even if we're not looking at the cultural factors and we're primarily focusing just on the data and the objects themselves, nonetheless, I think a lot of people are really interested, and I know I am too, in this apparent shift to the nighttime encounters. So what exactly might account for something along those lines? Specifically, one of the questions here is, can you do a correlation of their shift to nighttime behavior versus our average response time? For instance, what they describe are how quickly jets are able to be scrambled and dispatched to a location, things along those lines. Is there any kind of correlative that seems to account for that shift in terms of the time?
There are absolutely some correlations there. The shift, as Ian pointed out earlier, in the let's call the phase one, essentially the military focus through mid-1960s. A lot of that was related to radar detection, scrambling interceptors, a lot of it was the military response. But that was 24 hours a day, because literally, you know, you're talking national security, you're going to detect it 24/7. The interesting thing, that does not appear in this phase that begins occurring in the mid-60s that moves to nighttime, close encounter, loitering, really a different type of activity, which we're trying to call out by pointing out that early on, the optics were very clear. The UAPs made no effort to conceal themselves. They flew in formations. They did aerial displays. They made themselves very visible. So either they were intentionally doing this as an element of inferential communications, which we consider in our paper number 4, or they didn't care. You know, they were on a mission, they had a focus, I don't care. There could have even been a defensive element for the sightings. A lot of formation. I think we kind of lose track of this over time. There were a lot of multiple objects flying in formation in those early days. That all went away. And that when the daylight pattern shifted, what we see, as Ian has labeled as covert, it transitioned. Those nighttime observations are almost entirely non-military, except for the ones that have to do with ICBM bases. So these are not the same kind of people. They're not interceptors. They're not radar detection. These are 2 or 3 people in generally isolated areas in what Ian mapped out in the presentation. And they're either coming across the objects and the objects are doing something and they're literally encountering them. It's not necessarily like the objects are looking for them. Or in the case of the loitering incidents, the objects are simply circulating around an area through a protracted time. So it's a very different type of observation when we get into this nighttime phase, which inclines us to use, it's subjective. Does that really mean they're clandestine or covert? A better term might be less observable. But clearly they're not, their activities are different and they're not putting themselves in a highly observable mode like they were in the earlier years.
Thank you, Larry. And here a little later, we'll come back around to questions about what some of those behaviors could potentially indicate. Right now, Gary, I want to come back over to you for just a second on one. A question we have from Giorgio is there a way to weaken the stiffness of space-time by harnessing negative energy states that stimulate metamaterials? You kind of touched on this a bit in that overview.
Yeah, that's right. And this polarizable vacuum is one concept that points in that direction. Anything with a negative index of refraction or less than 1 unity negative index of refraction is going to give you a blue shift or a negative energy state. And likewise, a positive index material that's typical mass will give you a red shift, which slows down light, which is essentially, you know, a source of inertial mass. So you can do negative mass with less than 1 index or positive mass with greater than 1 index.
I'm really intrigued also about those potentials with regard to the observational data we have. I mean, what little we have, but still I think there's quite a bit that can be extracted from the Tic Tac, the famous 2004 footage obtained by Chad Underwood operating the at-FLIR targeting pod. And the inferred possibility that some of what you describe, particularly with the dynamics and the appearance of the craft in that footage being infrared, what that could potentially mean about the propulsion system.
It was a mystery that it looked colder than the background, right? And so that is one solution to it. It's not the only solution to it. There may be other explanations for why it appeared cold, but one solution would be, hey, especially since it's kind of glowing, that might be a blue shifted, you know, black body radiation. Yeah,
really interesting stuff. Peter, let's come over to you on this one. Would it be valuable to augment reports and also databases with standardized AI-generated images based on visual descriptions. I mean, there could obviously be some issues with that too, because it could project imagery into the mind that doesn't necessarily meet all the criteria, but it's an interesting question with the proliferation of AI. Could that kind of imagery be useful with maybe the database project?
You know, AI, the way it is now, can hallucinate, and you know, it's AI tries to please you, at least with the current, and if it doesn't have the proper data, it'll create something. It's rare, but it can happen. So there's a danger there of you know, trusting it too. You have to trust it. You have to be careful about it. But what it is good to is for pulling there may very well be an application for that, but I don't, off the top of my head, I can't say so, but I do, we have to be careful with AI. But what it is actually very good for is in context. Currently, like, you know, if it can go in, if there's a verbal description of, you know, like we showed the example of the submarine, you know, a shaped submarine in the sky, but within that series of events, one was an object at a submarine base. What the AI can do is go in and eliminate the submarine base, because it would find other aspects that would indicate that it's a base, not just the word. Mm-hmm. And so there's a lot of advantage in context. That's how we understand things, right? I mean, it's by words. Depends where they are in the sentence and what the adjective and verb are. You know, makes the word sensible. You know, and it can do that. You know, it isn't conscious and it isn't intelligent, but it has pattern recognition capabilities, extraordinary ones, that you know, separate those kind of things. And that's, we've never had that before. So that would be a huge addition, and we're going to build that into the database.
Fascinating.
But we're not, you know, I'll just say this. Mm-hmm. The tools will be there if you want to use them. We're going to, the database will be neutral. We won't filter anything. It'll be, I mean, obviously total junk. But, you know, some farmer in Bulgaria who saw something and reported it, we won't weight that less than a nuclear physicist who, and the idea is that, you know, suppose there's a very good event occurs on a certain day, but you could filter on that particular day and find out, perhaps track where these things came from. You know, it maybe came from Bulgaria, traveled across the ocean, you know, and, you know, there's new patterns that can be shown. And that's kind of the objective, you know, because, you know, to my opinion, they don't just come down and go up. You know, they're probably, you know, if there's 300 valid cases a year, there may be only 30 objects, you know, that were reported in different locations. It may be the same object. So those kind of things we can find out, you know, what's going on.
Indeed. Robert, let's come over to you on this one right here regarding shapes yet again. I mean, there's so many directions we can go with that, and that data is so intriguing, the way that you guys parsed it. Is there any information right now regarding whether that preponderance of shapes has changed over time? We've already seen a little of that, the two primary kinds being, again, the saucer, disc, or elliptical, and that some of those categories possibly having some overlap, and then secondary to that, those triangles. But I mean, is there any indication that there's been a preponderance of shapes having actually changed over time?
Yes, shapes have changed over time. This is what we will look at in our second paper, where we look at time and geographical area. We did not look at that yet in this paper, but I do know, for example, the triangle became much more prevalent in the 1970s through the 1990s. I believe, and this is where we need to do the second paper, I think the disc still dominated over the triangle, but the triangle got a lot bigger percentage of the pie during that time period.
Excellent. Thank you very much. Let me see if I can get another question in here for you, Gary. We've got a couple, courtesy of the folks at the Catastrophic Disclosure Podcast. Let's go with this one. With quantum superconducting materials, have you seen any work in quantum, what they call Hall effect? topological materials as candidate materials for lattice metamaterials. You may have to break down some of that terminology for us as well.
Yeah,
please.
I haven't specifically seen any Hall effect devices used in this manner, at least. Jack Sarfati has looked at a wide range of metamaterials in conjunction with his exploration of the Tic Tac encounters. And so I know that he has, and I don't have the exact list of metamaterials he's looked at, but it's tough to track his research down because he doesn't publish a lot. He puts a lot on the internet, but it doesn't go into journals. So I mean, we could look at that in more detail when it comes time to start looking at the phenomenology and the signatures of each of these types of devices. But Hall effect specifically, no.
Thank you for answering that. Occasionally, some of those things that Mr. Sarfati puts out end up in my email inbox as well, and actually I appreciate that. Jack's always putting great information out there. I'm not sure who I would direct this one to. I will invite any of our panelists to weigh in on this next question. One of our questioners asks, the use of the term anomalous puts us in a defensive position in the sense that we immediately sort of kind of place it outside of the bounds of where maybe we think in terms of current science. And so they say, it appears to me we are trying to expand the definition of normal maybe to unnormalized phenomena. Could that be a better term that implicitly establishes UAP as simply unexplored normal phenomena? Now, with relative to or relation to the study that you described, Robert, shape and size is not always clear since many sightings are orb-like or amorphous. So is there interest in establishing a formal ontology and taxonomy as an independent project?
I guess I'll touch on that. I think there does need to be a taxonomy for the whole subject of UAP/UFO. I will comment on why we wound up with UAP. And this comes from the UAP task force. And this was because Jay Stratton, who headed up the task force, needed and wanted to brief Congress on the status of UAP or UFOs or UAV or whatever you want to call them. And he did not believe that the use of the term UFO would help him in being able to brief Congress. So that's why the term UAP began to be used, which, although I'm not a fan of the term UAP, I can see why that was done, and I would applaud that it was done in order to achieve the objectives that he wanted to achieve.
Wasn't it Jack Valet who said UFOs are neither flying nor unidentified?
That's a good point, yeah. We might debate whether flight is the best term to use for the locomotion they appear to exhibit, right? This next question actually has to do with, again, a long-running organization. We've relied on their data for many years, and again, a scientific paper that I believe, I think it was Robert, you mentioned this earlier, dealt with this, and this, again, was a peer-reviewed published paper. It dealt with data collected by the National UFO Reporting Center. But there's another, the National Aviation Reporting Center for Anomalous Phenomena, or NARCAP, and one of our questioners asks, has NARCAP data been included in any of these studies presented? One might presume a higher overall quality or veracity of the reporting given that those were direct pilot reports.
I can tell you that, yes, some NARCAP reports made our list of 301 cases. For example, the Chicago O'Hare report of 2004 or 2001 maybe. So I know that was in our database, and I think there were a couple of other NARCAP reports.
Let me see here. We're still getting through some of these. We seem to assume a stasis. In other words, just kind of this pause in UAP-related technology over the last 70-plus years. The questioner asks, should we presume a Moore's Law-like evolution as well as a diversity in sources and asymmetry in potential UAP owners? It's a roundabout way, I guess, of asking. I mean, should we presume that there is change over time as well as diversity in terms of who is operating these craft?
Well, I would imagine that the physical underlying principles would eventually optimize, on certain types of, it's like you know, look at cars, right? In 1900, the cars were boxy and clunky and whatever, and now we have Teslas and, you know, Ferraris and all the other thing. But essentially, it's still got four wheels and, you know, but it's just more streamlined and optimized and whatever. So there's probably a limit, you know, to what you can do, unless you can, you know, unless you can do teleportation or something. But that seems like very dangerous. If a transistor blows out, you know, you might turn into spaghetti or something, you know.
So I might comment on that a little bit also. As Peter said, I mean, it's very difficult, right, to say, okay, are the source of these different objects just one origin, or is it multiple origins, right? We can't truly know that. But I would argue the following deductively, which is that I think you could make an argument better that there are zero sources, right, of origin for UAP. In other words, it's totally non-existent before you could make the argument there's only one, right? Because anytime there's one, just from experience in life, right, there's always more than one. So if we believe that there is life out in the universe and it's found us, it's very difficult to argue, to me, that there is only one that has found us. It's like going fishing in a lake and I catch a bass and I only expect that to be the only type of fish that I catch. I would bet money that there are other types.
Excellent responses. One more I'd like to work in, and if Larry Hancock is still with us, he may want to chime in on this as well. We look at the intentions study, we look at the changes in the appearance of craft over time, and also the prevalence of certain different types. Even with some of those atomic warfare complex incidents that were analyzed by Ian and Larry, we do at least have a few where there were observations of occupants. Back in the 1950s, this was once, one of those taboos that we've talked about a little. Dr. Mossbridge addressed this topic, and others have as well. NICAP, the National Investigations Committee on Aerial Phenomena, for a time was very concerned about actively engaging in claims that involved anything apart from just the physical objects, the technology. The idea that someone or something could be operating them, yet again, was a taboo. That changed over time, although I would argue today we're sort of back in that place. And there are maybe some legitimate reasons why we want to exercise caution in approaching the topic in terms of, well, who's driving these things and where are they from? But when we are dealing with the potential for exotic technologies, that is obviously a possibility that must be entertained, and therefore there's data related to what the operators may do, how they operate, what they look like, and other things. So my question would be, in the scope of both maybe the intentions studies, the ongoing studies in that forthcoming paper, but also in trends and analysis that's been done with regard to the objects, how can we apply that toward the idea of, A, the motives and intent of the operators, as well as maybe the operators themselves? Maybe
I can jump in on that one because we specifically did that when we entered into the public space for our pattern studies. We determined that we would not exclude reports of contacts with operators, visible reports of operators, or contact type activities, communications type activities. So we did determine that we would include all of those types of activities in our public study, and it's already out there in our pattern analysis. I will say one of the things that we did find is we found in the reports that we were using relatively few of those, and actually so few that we couldn't identify any patterns. They're there, and you'll see the ones that we selected. We just could not identify any patterns in terms of the occupants. We definitely have identified patterns in regard to their activities, and as time goes on. And I think this relates to, I would speculate that, and the question you just asked, can you relate a trend over time in shape or size? And we do see that occurring in regard to the black triangles. The black triangles do correlate very well in time with the advent of more close approaches, what you might describe as inferential communications, and this starts occurring over a specific period of time. So we think we can do that. Rather than looking at individuals, though, we looked at inferential communications, and we looked at activities that might be interpreted, quite frankly, in other terms, such as behavioral studies, ethological studies. So we did enter into that other venue, and you're going to see us considering some activities that have been considered taboo in the past. And we will discuss that. We introduced it in paper 3, and we'll come down on our evaluations of which of those activities we find most probable. And by the way, I will say, what we're doing with this type of analysis is very similar to the hypothesis probability approach that was discussed on the first day.
That's just the kind of answer I'd hoped you'd give us there, Mr. Hancock. And again, you know, I know there's some people probably out there listening who are just screaming to themselves, come on, you're talking about aliens, just go ahead and just say what you mean. There's a reason why we use very specific language. And that I think that this speaks to the efforts of the Scientific Coalition for UAP Studies over time. If we want to do better and we want to analyze this and really understand what it means, we've got to elevate the way we talk about this phenomenon too. And that's not to the exclusion of these ideas, but there's a responsible way to apply science and actually to apply scientific language toward this as well. And hence why we frame it like that. And again, Larry, you couldn't have answered that question any better. I look forward to these ongoing studies. Any final commentary from our panelists on the broad nature of these studies, where we're going, what we hope to achieve, and what people can look forward to?
Well, you know, we want to move it. We want to make this, people understand that this is a real subject that's worth studying, you know, that science, they've been reporting these things for at least 70 years, back to World War II, and probably long before that. But you know, with more information in the last 70 years, you know, and you know, I came up with the term, you know, enigma or stigma, you know, and there should. Why are we afraid to look at this? You know, there's just too many reports of too many things, and it's not by reputable people. So that's what I'm a skeptic, you know, by nature, but I've come to think there's something to this. You know, there's just too many ordinary and qualified people who've seen these things, and it's just ridiculous to think they're all making it up. They have nothing to gain from it. You know, so.
Absolutely. Any final closing remarks?
Yeah, the only thing I wanted to say is the progress we've made over time. If you go back and look 30 years ago, we had what was called the Invisible College, right? And those were academics who wanted to study the subject but didn't want anyone to know their names. Well, look at where we're at today. You have the Sol Foundation, you have Galileo Project, you have SCU, you have UAPX, you have SWAPS, you have multiple organizations with many academics within it, and we're beginning to get graduate students and college students involved. And I think the solution to this subject, you know, short of perhaps the government saying, here's what we know, and I don't think that we can count on that. So my view is we need to drive this towards academia. And that's the way I think we finally have to study it, because think about this. If the possibility is correct and what we're looking at are indications of an intelligence that at some point in time we have first contact, who do we want that first contact to be our representatives? Shouldn't it be academia or a civilian group or the United Nations rather than one of the major nations' military organizations? The latter is not what I want for a first contact.
Gary?
I think science can be brought to bear on this, and that's why I think you formed the SCU, and I'm happy to be part of it. I'm thrilled to be part of it.
We're thrilled to have you. Again, please congratulate our excellent panelists. Some really thought-provoking analysis going on here. And again, I hope that everybody out there, those here present in Huntsville and those watching at home, you can see the kinds of rigorous analysis, deeply insightful studies, and ongoing research that SCU is undertaking right now. and we're not done yet.